All right. Now let's have a look at question 1A. This is our first question as potential future chemical engineers. So let's begin. They say to you, do the following conversion, and they want us to convert a flow rate of 30 cubic meters per day to cm cubed per second. So as soon as you see a question like this, you can see that they've given you a flow rate. And the first thing I want you to remember is, as a chemical engineer, there are three kinds of flow rates you are going to encounter that are most commonly used. Okay, if you don't see any other flow rates, you will often see these three. So the first is what happened there? The first is the volumetric flow rate. Okay. The second is the mass flow rate. Volumetric flow, mass flow, and the third one is the molar flow. And I think just based on the title, you can already guess what each of these flow rates refers to. But the volumetric flow rate is some kind of volume passing a specific point in a pipe per unit time. So it's expressed as volume per time, for example, cubic meters per day. The next kind of flow rate you'll experience is a mass flow rate. So that's some unit of mass per unit time. And the third kind of flow rate you'll experience is some number of moles passing through a particular point in a pipe per unit time. And all of that, you can make a note, is the three most common expressions for flow rate that you will encounter. So I'm going to scroll down a bit and let's continue with this question. So we've got 30 cubic meters per day. All right. And they want us to convert that to cm cubed per second. So let's just have a discussion about this ladder method. The ladder method is how I'm going to do all of the conversions in this course. And what I want you to know here is, when I started university, I said to myself, you know what? I know how to do conversions my own way. I'm not going to follow their rules. I can do this thing on my own. And so I went about doing conversions the way that I learned in school. Now that's perfectly fine. There is no correct way to do maths. But I do wholeheartedly believe that if there was a better way than the ladder method, then eventually it would be the method that we all adopted because it is the fastest. And so the fact that the ladder method is so commonly used in memos and by lecturers means that it probably is the best solution we have right now. Okay? Of course, if you're fine doing the conversions your own way, that's okay. But I'm going to use the ladder method for now. And that's because that's the method I believe is the fastest and the most efficient way of doing things. So we've got 30 cubic meters per day. And I always like to write down what the target conversion is. What do we want to get this into? So our cubic meters is going to be converted to cm cubed. So I'm just going to make a note here that my m cubed needs to be converted to cm cubed. All right. And I also want to make a note that day per day needs to be converted to per second. So I'm just going to make a note here that my target is to get days into seconds. All right. So let's continue. Now, the first thing I see is that we've got cubic meters here. And then, of course, you might say to yourself, well, all right, I know that 100 centimeters makes a meter. That's easy. Everyone knows that. But how in the world do I convert cubic meters to cubic centimeters? And then you start to freak out a little bit, right? So here's what you do. Start with what you know. I know that 1 meter is the same as 100 centimeters. And I'm sure you'll agree with me on that. Now, why did I put meters at the bottom? I put meters at the bottom because it can cancel with my meters at the top here. All right? The next thing all you have to do is, because you have cubic meters, you want to cube the bottom bracket, and then you want to cube the top bracket. Now, from your exponential laws in school, this is just a note. Remember, if you've got a 3 outside of a bracket, you need to distribute it into the number as well as the unit. Same thing at the top. Exponential law tells you if you've got an exponent outside the bracket, you need to distribute it into the bracket. And so that way, my meters is going to become cubic meters, and my 1 is going to become 1 cubed. My 3 is going to be distributed into the 100 to become 100 cubed. And my cm is also going to be cubed to become cm cubed. And that is how you tackle the issue of cubic units in your ladder. Okay. So you can take your pen now and you can quickly go and cross out what you want to. So you can see that cubic meters and cubic meters cancel, and we are left with cm cubed. So we've already achieved the first part of the question. Now let's continue. I'm going to draw a line here and let's sort out this day. Well, I know that one day is the same as 24 hours, right? And I'm going to draw a line there. And why did I write day at the top? Because day at the top cancels with day at the bottom. All right. Just for consistency, let me do that in red. So all our cancellations take place in red. All right. Next, I can say to you, well, I know that 1 hour is the same as 60 minutes. Okay. And I can also tell you that 1 minute is the same as 60 seconds. And why did I do this? Because again, you can follow my logic. Hours at the bottom cancels with hours at the top. Minutes at the bottom cancels with minutes at the top. And I'm just left with seconds. So now my final unit is seconds at the bottom and cubic centimeters at the top. And so I have accomplished the objective of the question. So now I'm going to show you what this turns into. You might say, well, okay, I've done the ladder, but now what do I do with this ladder to get an actual number? All you do is extract the numbers out of the ladder. So I've got 30 multiplied by, and this is all the top section of this ladder, all right? Multiplied by 100, remember the 100 is cubed, multiplied by 1, multiplied by 1, multiplied by 1. Now, of course, once you get advanced and experienced at this, you don't have to show the multiply by 1. You can even skip this whole step. But I'm doing this with you because it's one of the first conversions you do, and I want you to feel comfortable with it. And to make it even more clear, I'm going to show you with an arrow where each of the numbers comes from. So the 30 comes from here, 100 cubed comes from here, 1 comes from here, the other one is coming from there, and the last one comes from here. Fine? Okay. Now I can draw my line. And then at the bottom, this is actually 1 day, right? So if you say per day, it's per 1 day. Okay, so that's 1 multiplied by 1 cubed, multiplied by 24, multiplied by 60, multiplied by 60. Okay. Now you might be thinking, why would you write 1 cubed? That's the same as 1. I know, but this is just to show you that it's very important that you don't forget that cube in there. Okay. So that is equal to, if my calculations are correct, you should end up with 347.22 cm cubed per second. And that is your final answer. Now, I just want to take a moment, change my highlighter color, and show you how to double check everything on the ladder to see that it's correct. So here's the thing, right? If every stage of your ladder is essentially equal to 1, or is the top and bottom are equivalent, then your ladder is correct. So let me show you what I mean by that. Do you agree that 1 meter and 100 centimeters is exactly the same thing? Yes. So therefore, my top and bottom is equal to 1. Let's go on to the next block of the ladder. Do you agree that 1 day and 24 hours is exactly the same thing? Yes? Okay, good. That is equal to 1. Do you agree that 1 hour and 60 minutes is exactly the same thing? Yes. So that is also equal to 1. And do you agree that 1 minute and 60 seconds is exactly the same thing? Yes. So that is also equal to 1. So if I take any number and I am essentially multiplying it by 1, then do you agree that mathematically I have not changed that number at all? I've only converted the units of the number, but the actual meaning of the number is only multiplied by 1. And so that's how you know that your final answer is the equivalent of what you started with. So that is the mathematical proof of why the ladder method works. Of course, if you were just happy getting to the answer and you are fine with that, that's cool, that's perfect. But I know a lot of people, it kind of bugs them if they don't know how they got to the answer. And so this is the mathematical proof behind the ladder method. So I hope you found that helpful. Let's move on to the next question.